All right, this is the triangle congruence review we did in class on December 4th, Wednesday, December 4th for the quiz. So we want to write a congruency statement for the two triangles. So a congruency statement is just saying that our two triangles are congruent. So there's 6 different ways you can name the first triangle. You can name it triangle CAR, CRA, ACR, ARC, RAC, RCA. Any one of those will be fine. I'm going to name it triangle CAR. Doesn't matter how you name the first one, but the second one does matter. The order is going to matter. So C here is between the 1 hash mark and the 2 hash marks. So we need to look for the 1 and 2 hash marks over here, and that's going to be G. So C is going to correspond with G. A is between the 1 and the 3. Okay, so between the 1 and the 3 over here is E. So I'm going to put in E. And then R is between the 2 and the 3. Okay, so R is going to correspond with L. So triangle CAR is congruent to triangle GEL. Again, we could have named this a different way if you would have named this triangle ACR. Right? Then you would have done A corresponded with E, C corresponded with G, and then R corresponds with L. Okay, so you only need one way, 6 different ways to write it, but you just got to pick one. Okay, so that's triangle congruency statement. Okay, for number 2 here, it says list all of the congruent parts for the triangles. So all we got to do is look at our names here. Okay, so triangle EF, G, and triangle HGF. So this is going to tell us that EF is congruent to HG. Okay, we know that FG is congruent to GF. Okay, and then we know that EG is congruent to HF. Okay, and we're just getting that simply from the order of the sides. Okay, EF is congruent to HG, FG is congruent to GF, and then EG is congruent to HF. Okay, and then we can fill in our angles here. So angle E is congruent to angle H. Angle F is congruent to angle G. Then angle G is congruent to angle F. Okay, we notice here, though, we have a little bit of an issue. So we have to look at our two triangles. They are going to have a shared side, right? We know FG and GF. So if we make this triangle EFG, okay, we're then going to have triangle HGF. Okay, and if we look at our statement, we know EF is congruent to HG. We know that FG is congruent to GF. And we know that EG is congruent to FH. Okay, we know angle E is congruent to angle H. Okay, this angle, which we probably want to rename now, we want to rename it with 3 points. So let's say angle EFG is congruent to angle HGF. Okay, and the third pair of angles here would be angle, instead of naming it angle G, angle EGF is congruent to angle HFG. So that would be what our diagram looks like. Okay, but if you don't draw the diagram and you just use it from here, that's fine. That's kind of the idea we're looking for. Number 3 here. Then we want to look for, are the triangles congruent? If they are, what postulate tells us they're congruent? And then we want to write a triangle congruency statement. Okay, so here we're given 1 pair of sides and 1 pair of angles. We can use the reflexive property to show that BD is congruent to BD. We then can use side, angle, side to show the triangles are congruent. Okay. They're giving us triangle ABD. So A would correspond with C, so it's going to be triangle C. B has 1 arc in each one, so it's going to be B. and then D. Right, so triangle ABD corresponds with triangle CBD. Okay, here we have two pair of sides. Okay, but there's nothing else we can fill in. So we're going to say not possible. Okay, not those two. We don't have enough information to determine if they are congruent. So not possible. Okay, which means we have nothing for here. Over here we have two pair of sides and an angle. So we have angle side side. And again, we don't have angle side side. We can't use that one. There's nothing else we can fill in. We can't use HL because we don't have right angles. So we're going to have to conclude that we do not have enough information to determine if these triangles are congruent or not. So not possible. We don't have enough information. The next three on number 3, we're given 3 pair of congruent sides here. So we're going to use side, side, side. Okay, so triangle STU. Okay, so S is between the 2 and the 3, so that's going to correspond with V. T is between the 1 and the 2, so it's going to correspond with X. And then U is between the 1 and the 3, so that's going to correspond with W. So triangle STU is congruent to triangle VXW. So basically, we would be rotating this triangle upside down. We'd be doing a 180-degree rotation, and then they would line up. Okay, here we have a right angle. That means we have perpendicular lines. So that means both of these are right angles. So we have one pair of congruent angles. We can use the reflexive property to say that AY is congruent to AY. That gives us one pair of sides. But all we have is one pair of sides and one angle. We don't have enough information, so we have to conclude that it's not possible to determine if they are congruent or not. Over here, we have two pair of sides and one pair of angles. Okay, the pair of angles is between the two pair of sides, so we have side, angle, side, which tells us triangle CDE is congruent to triangle. So C is going to correspond with F. D corresponds with G, and E corresponds with H. The next set here, we can use the reflexive property. Okay, and then we can have side, angle, side. Okay, so KJM is our first triangle. K in the first triangle has one arc, so it's going to correspond with M in the next one. J is going to correspond with L. And then M in this triangle, M in the first triangle is this one. It's going to correspond with K in the other triangle. Okay. This one you have shared sides, so you have three pair of congruent sides, so you use side, side, side. NPR, so N corresponds with Q. It's between the 1 and the 2. P corresponds with P, and R corresponds with R. Over here we have vertical angles. And that's it. So now we can do angle side side, but that's not one of our postulates. So we have to conclude that we don't have enough information to conclude if these triangles are congruent or not. So not possible. Number 4 is very similar, except instead of putting everything in the diagram, they have it written on the side. So let's look at the first two from number 4 and just fill it in ourselves. All we got to do is fill it in ourselves. CD is congruent to AB. Angle B is congruent to angle D. Okay, we have vertical angles here. Okay, so we can fill in our vertical angles as well. And now we have angle, angle, side will tell us triangle CDE. So C is going to correspond with A. D is going to correspond with B. And E corresponds with E. Okay, here they give us everything. You just got to fill it in. JN is congruent to LM. NK is congruent to MK. And angle N is congruent to angle M. That's side, angle, side. Two pair of sides, one pair of angle. The side or the angle is included, meaning it's between the two pair of sides. So side, angle, side tells us the triangles are congruent. So JKN. So J is going to correspond with L. K is going to correspond with K. And then N is going to correspond with N. So triangle LK. Right here we have AC is congruent to BD. Okay, we also have, I don't know what the best way to mark this is, but these two pieces are congruent, right? The whole thing is BD, CB, EC, and AD. Okay, we also have the reflexive property. Okay, so we know now that this triangle here is going to be congruent to this triangle here, right? Because AB is part of both triangles, so it's a shared side, reflexive property. Okay, so we now have side, side, side. Okay, so that shows triangle ABC is congruent to triangle BAD. Right, A in this triangle is between the 1 and the 3. So it's going to correspond with B in the other triangle because that's between the 1 and the 3. B in the first triangle is between the 2 and the 3. So that's going to correspond with A because A in the second triangle is between 2 and 3. C is between 1 and 2. And then D is between 1 and 2. Right, this one we have bisectors. So it's saying that SQ and PR bisect each other. That means they split each other in half. So they're going to cut each other into two congruent parts. So because SQ bisects PR, we know that PT is congruent to TR. And we know because PR bisects SQ, we know that ST is congruent to TQ. We have vertical angles, so we can fill those in. Now we can use side angle side to show that the two triangles are congruent. So RST would be congruent to PQ. R is on the other side of the 1, so P is on the other side of the 1. Q is on the other side of the 2, so S is on the other side of the Q, or S is on the other side of the Q, so the 2, so Q is on the other side of the 2, and then T is in the middle. Triangle PQT. Okay, number 5 here, what other information do you need in order to prove triangles are congruent using side angle side? So we can use the reflexive property. That gives us 2 pair of congruent sides. To use side angle side, we need 1 pair of congruent angles that's between the 2 sides, so the included angle. So that's going to be these angles right here. So we need to show that they're congruent. So this is angle BCA is congruent to angle DCA. Okay, it's asking us what additional information we need in order to use side angle side. This is what they would have to give us. We would need to know that those angles are congruent. Six, 7, and 8. Oh, click no. Okay, what additional information do we need to use angle side? So right now we have 1 pair of angles congruent and 1 pair of sides. So to use angle side, we need another pair of angles. We have 2 choices. We could do J and F. If we did J and F, we would then have angle side angle though. We want angle side. So the additional information we would need would be angle L is congruent to angle G. Okay, if we had that, we would then know we had angle side. Okay, number 7, you have reflexive property. HL has 3 requirements. You need a hypotenuse is congruent, a pair of legs congruent, and you need to have right triangles. So because we have right angles here, we have right triangles. The hypotenuse of this one is SQ, and the hypotenuse of this one is also SQ. So we have the congruent hypotenuses. So we would then need a pair of legs congruent. So we can either do PS is congruent to QR. That would be our 1 pair of legs. Or we could do our other pair of legs, PQ is congruent to SR. Okay. You could also do that these 2 are congruent and those 2 are congruent. So there actually are 4 different ways. But that's fine. Okay, the last one, we have vertical angles. And that's it. So what additional information do we need for angle side angle? We need the pair of sides that's between the 2 angles. So we would need WX and an XT. So we would need WX to be congruent to ZX. Okay. So that's what we need in order to use those theorems on those triangles. And now let's get to the 2 proofs. are pretty small. Okay. So we have three givens here. Let's write our three givens. AD bisects BC at E. Okay, we have AB is perpendicular to BC. We have DC is perpendicular to BC. That's your given. So first thing on the list we have is vertical angles, so we can do vertical angle theorem. Okay, so we know angle BEA is going to be congruent to angle CED. If we go down our list, we don't have shared sides, we don't have a midpoint, we do have a bisector. So bisectors split things in half. So it's telling us that AD bisects BC. So BC, segment BC here, is getting bisected by AD. Means it's cutting in half, so we know BE is congruent to EC. And that's the definition of a bisector. A segment bisector. You can just put definition of a bisector, it's fine. Okay. Go back to our list because we only have two congruent statements so far. We don't have parallel lines. We do have perpendicular lines though. We know that perpendicular lines give us right angles. So because AB is perpendicular to BC, we know we have a right angle here. And because DC is perpendicular to BC, we know we have a right angle here. So we know that angle ABE, okay, and angle DCE, we know that they are right angles. Okay, and that's the definition of perpendicular. Perpendicular lines form right angles. Okay. Because we have right angles, we can use the right angle theorem. That tells us right angles are congruent. So now we can say that angle ABE is congruent to angle DCE by the right angle theorem. So whenever you have perpendicular lines, you want to say that you have right angles by the definition of perpendicular, and then you want to say they're congruent by the right angle theorem. Unless you're going to use HL, then you want to say you have right angles by the definition of perpendicular, and then you want to say that those triangles are right triangles by the definition of a right triangle. Okay, now we have three congruent statements. So we have angle, side, angle. Okay, so we can now use angle, side, angle to show that our two triangles are congruent. So triangle ABE is congruent to triangle DCE. Okay. And that's that. Now we know the triangles are the same size and shape. So get number 10. So they're giving us two triangles here. We know that C is the midpoint of BD and AE. That is our given. Okay, let's go right down the list. First is vertical angles, and we do have vertical angles. So we know by the vertical angle theorem that vertical angles are congruent. Okay, so our vertical angles are angle AACB and angle FCD. We only have one piece of congruent information, so we have to continue down our list. So shared sides, no. Midpoint, yes, we have two midpoints. We know C is the midpoint of BD. Since C is the midpoint of BD, we know that BC is going to be congruent to CD. Okay, that's definition of a midpoint. Okay, we also know that C is the midpoint of AE. So since C is the midpoint of AE, it splits it in half. So AC is going to be congruent to CE. Okay, and that is, again, your definition of a midpoint. So now we have two pair of sides, one pair of angles. So we have side, angle, side. And that will tell us our triangles are congruent. Triangle ABC is congruent to triangle EDC. Okay, there it is. So if you can do everything on here and everything on the one from Tuesday, the proofs booklet with the fill in the blank proofs, we should be good for the quiz, and then all the information from here on the test as well.